I'm going to tell a story, the story based on our work, some of them fairly recent. My work is not ecosystem. I'm a civil engineer, trained as a hydraulic engineer, did lots of work on water, floods, hydropower, water supply, but gradually kind of, sort of veered into climate adaptation, resilience, and last year and a half I've been working around issues of ecosystem and ecosystem-based adaptation. So that's the sort of entry point. And about 5 years ago, we were able to complete a study for ESPA, where we looked at the changing role of ecosystem globally, and then to identify some research questions. This was the changing urban-rural relationship, and then looking at ecosystem services. So that's the kind of a context. So my story has about 5 or 6 chapters, a bit loosely connected, and one chapter is something that I have recently coming in. So there might be a little bit of a lack of understanding in what I present, but then I'd like to request you to bear with me. Let's see. Oh, sorry. Yes? Yeah. So I'm going to, again, sort of broadly limit myself within a context of Nepal. But then, again, the lessons, the learning has sort of a wider relevance and implications. I'm going to talk about ecosystems. I'm going to talk about the changing urban-rural relationship and how that kind of impinges on the research and policy questions that we are engaged in. I'm going to talk about climate change, and then a little bit on adaptation and resilience. And finally, I'll throw some questions, and then I'll end by putting some concluding thoughts, as Paul suggested, as to how we might move forward. The physical context. Clearly, a small landlocked country between Tibet, China, and India, as you can see, has highest mountains in the world, as well as the Gangetic Plain at about 200 kilometers. So small horizontal crow flying distance, but then a very wide ecosystem, society, and other kind of diversity. So it represents as a pretty interesting kind of a test case where you could begin to look at what climate change and these changing contexts mean and how we begin to reconcile and deal with that complexity. Broadly gets fed by 2 types of rain systems that comes from the Bay of Bengal and then Arabian Sea, called the summer monsoon, lasts for 4 months. But then we also get rains from the Mediterranean, called the westerly, towards this part of the year, and brings in snow and brings in a little bit of winter rain. And that's the kind of a cycle that has continued. Now what this gives is a landscape where, though under the influence of monsoon, represents or embodies sort of a spatial variation in terms of how the rainfall happens. As you can see, the blue represents about 5,000 millimeter, and the yellow is here about 250 millimeter. The area where ESPA is funding one of the research, the study that Deepak Podel presented this morning. And as you move from east to west, the amount of rainfall goes on increasing, and as you can see, you find lots of regional variations. Sorry. Yeah. Let me go back. One more time. One more time. Yeah. Now, what you have is, one more time, please. One more time. One more time. Yeah. What you have is, this is the Annapurna and Dhaulagiri mountain range, and then there was a very stark windward and leeward effect. So this side of the mountain gets about 5,000 millimeter, and this side, which is the part of the Tibetan plateau, gets about 250, 230 millimeter. And most of the rain traditionally here would be in the form of snow. Now, that being the case, you would assume, yes, okay, but there are more local specificities. So same area where you have 5,000 millimeter rainfall, if you look at the micro context of a sub-watershed, you have very stark characteristic and what we call the micro level characteristic. So in the valleys and in the hilltop, you could have heavy rain and you could have very light rain, and you're not very sure when what would happen. So this gives us what we call a kind of a micro level characteristic, and it is within these three types, the macro, the meso, and the micro rainfall characteristic, the monsoon Himalayan landscape in Nepal and also Sikkim and West India evolved. And these have given to, in Nepal, three types of rivers, those that get water from snow in the north. And these are four major basins. And then we have basins which are not snow-fed, which are exclusively fed by the monsoon rains. These are called the second grade or the Mahabharat rivers. And then we have the third category of rivers on the southern face of the Mahabharat. This is the Chure or the Shivalik rivers. And these are pretty flashy, low dry season flow, bring in flash floods and a lot of sediment. And although under the influence of monsoon, each of these rivers have very distinct hydrological characteristics. And then with that characteristics comes the socio-economic context. And as you can see, you have the snow-fed basin, you have base flow, you have rainfall, you have snow melt, and you have ice melt. These are the larger four basins. And then you have the Mahabharat rivers, you have the base flow, you have the snow melt, not ice melt, a little bit of a snow melt, you have mostly rainfall, and then the Chure rivers where you have rainfall and you have the base flow. And this constitutes the sort of a broad water within which the natural ecosystem exists. Now the ecosystems can be broadly classified into the terrestrial ecosystem consisting of agro-ecosystems, grassland ecosystems, and forest ecosystems, and the freshwater ecosystem consisting of paddy fields. You know, in Nepal there are a lot of terraces and the paddy fields which store a lot of water, regulate flow, conserve sediments, and also maintain the cereal production. And then you have ponds, you have lakes, you have marshland, and rivers. About 6,000 rivers of different lengths, 225 billion cubic meter annual river flow, strong temporal and spatial sort of characteristics. Almost 80 to 90% of that flow occurs in the 4 monsoon months. And then as expected, because it drains the Himalayan mountain, it is one of the highest sediment content in the rivers. The river system essentially has a river channel, it has a floodplain, it has land and land use types in the riparian area which is directly linked to the river, and then human habitat, the agricultural land, forest, grassland, wetlands, biodiversity, and then there is processes which kind of link these elements. The hydrological process of production and distribution of water, the geological process governs erosion and sedimentation, the biochemical process, this integration and synthesis and nutrient cycling, and the biological process, conversion of water, nutrients, and energy into food that we consume. And then these elements and processes link together or conjoin together to produce different kinds of goods and services. And when you look at river systems, you essentially think of two different types. One is the natural type, the natural ecosystem, which functions all types of use, while you maintain the ecosystem integrity. But at the same time, you have human-engineered system within that river. These are built, these are constructed at different times, engineered locally, engineered through state or other intervention, satisfying irrigation, municipal, industrial, and other kind of consumptive as well as non-consumptive use such as power generation and flood control. And all these aim to enhance human welfare, but generally at the cost of environmental integrity and sensitivity. Yeah. Now, over the past sort of 50, 60, 70 years, if you look at the history, the character of human engineered system has been what I call unidimensional and unidirectional. It mostly focuses on expanding the provisioning service and to some extent maintaining or enhancing the regulating service. such as dams and flood control embankments and the interbasin river water transfer. The cultural and supporting systems sort of either are compromised or ignored. And the social and environmental costs are largely externalized in time, in society, and others. Yeah. So that is then brings us this question of knowledge that Dr. Oza was talking about yesterday morning. Clearly, the understanding of river hydraulics and river engineering in this part of the world has a limitation because the science as we understand it, and then Dr. Sinha can sort of add on to it, and I'm clearly, some of the work that he has done really highlights this limitation. The science has actually evolved on part of a geography where the climate is very, very different. Not the kind of dynamic pulse climate system that we experience in this part of the world. The rivers, for example, are very dynamic. The Kosi River has moved 220 kilometers in the last 150 years. So you can find all the rivers in the plains moving as if they are pendulums. And that's been the characteristic of this river. So we have very limited evidence on the behavior of regional climate. We know something about the climate, but when you actually go to actually understanding the interrelationship between the land, the landscape, and climate, we sort of fill into a gap. And the IPCC 4 designated Himalayan region as a white spot because of lack of monitoring as well as lack of peer-reviewed literature. And as a result, there is oversimplification of process. And the method has preponderance towards construction, mostly hardware-based technological solution. And then non-technical solutions are sort of, rather given very, very low consideration. There is deficit in data, precipitation, river flow, sedimentation, river behavior, and then the ecosystem relationship. And also there is knowledge deficit in accounting for, particularly in relation to ecosystem service, supporting, regulating, and cultural services. Now, having said that, I've made some attempt to kind of, I'm sorry, the white can't be sort of seen, prepare a schematic of putting together all the different services, the provisioning, the regulating, the cultural, as well as the supporting services of ecosystems in a sort of a broad national context. So clearly what you have in the Himalaya, where lots of ponds, and you have tourism, you have hydroelectric dam, you have ponds that recharge, you have wetlands in the Tarai, you have urban areas, you have river rafting, you have irrigation, all kind of things kind of simultaneously exist. It's indeed something what Paul talked yesterday. It's indeed a mosaic. But then you intertwine this mosaic with the ongoing social and political change, and essentially what you end up is a fluid mosaic. A mosaic that's changing. Now, how do you deal with this fluid mosaic? That's a question I like to get at the end. So what it does, again, is I try to put some numbers here. Despite limitation in data, I try to put some numbers into these different categories. You have agricultural land, and you have forest, and you have rivers, and you have hydropower, certain percentage, energy generation, solar, biogas, exploitable minerals, different kinds of plants. And then you have regulating service, the mountains condensing paper and providing that sort of a regulating service. The microclimate which modulates temperature and wind patterns. The forest which produce and nurture and support groundwater aquifer system. The traditional and modern hydro structures, lakes, both in the Himalayas, the glacial lakes, and other types of lakes. Different types of vegetation. And you could go to the cultural service, very attractive tourist destination. Different kinds of safaris, trekking, mountaineering, whitewater rafting. Now, paragliding has taken on a big scale in Nepal. Lots of Hindu temples and Buddhist shrines. So about 8.5 million tourists visit Nepal every year. Gives jobs to about 500,000 people. It provides some contributions to GDP, about 4.3%. And clearly, as that society has developed, lots of indigenous knowledge, local practices in managing water, managing forest, managing natural resource, agriculture, so on and so forth. And then the kind of supporting service. Now, so within this whole relation between how we conceived urban, rural, changing very fast. Just a map of South Asia, NASA's map, and what analysts tell us is in the next 15 years, 60% of world's people will live in cities, and most of them in, one more time, I wanted to say this. So Homo sapiens becoming Homo sapiens urbanus. So this is actually from State of Cities, not mine. But now let me go to Kathmandu. Nepal. About 58 municipalities. Now even a rural area has become a municipality now because of political compulsion. So numbers now about 130. 70% of our population is urban, and in Kathmandu it's about 2.5 million, and there is a lot of what we call floating population. And somebody also showed this graph in the morning. This was 1967, 1978, 1991, 2000, next 2009, 2006. Clearly the urban space is just ballooning, and it's ballooning at the cost of the rural areas, at the cost of the wetlands, the ponds, all kind of degradation that is associated with urbanization. At the same time, you also see a kind of citizens' initiatives where people have begun, for example, rooftop gardening, rooftop vegetation farming. It's kind of gradually picking up in Kathmandu. So it's not a sort of a one-way street, it's just degradation going down. And in fact, last 6 to 8 months, people of Kathmandu gather around the river, Bagmati River, and clean it of its solid waste that's been done over the last 20 years. So kind of an imagination has sort of caught on. So you see this tension, both outward and inward kind of a process going on. Now how do we understand this? Traditionally we thought, the urban and rural were sort of very distinct ends of the spectrum. Clearly what we have is both rural and urban penetrating into each other. And then what we have is what's called Desa Kota region. This was Thierry McGee, after his work in Indonesia, using this term. This was again a study that we did for ESPA in 2008. What it shows is in Pakistan, if we look at two rural areas around Quetta, Pishin and Mushtong, you have rural influence gradually depleting and urban influence extremely increasing fast. And a region of Desa Kota where all kind of things are happening. So rural institutions that manage ecosystems have ceased functioning or have lost influence, and the urban institutions really have not extended their influence or scope of activity in that area. So you have a kind of a transition, anarchic space of process that's going on, and then you see that all over South Asia as well as in Nepal. Now 30 years ago, life in Nepal depended on forest, livestock and crops, provided a sort of interdependent fodder, fuel, maintained a family livelihood and sort of an asset basket. That was all right. Now if you look at it, it has changed. Though the cover of forest over the last 30 years has increased significantly, we have pockets of deforestation. But what we have now is a massive youth migration. Massive youth migration, and we talked about it yesterday, feminization of agriculture, land being left fallow, remittance income coming in, and that contributing a kind of an income addition to families, and then in some way contributing to poverty reduction, and then bring in all different kind of changes. And then of course the relation between crops and livestock, more hybrid seed, more use of commercial fertilizers and so on and so forth. So clearly a very different space that's emerging, and we still need to sort of track what the hell is going on and how to make sense of all this within that fluid mosaic. Now this is a study that we did in peri-urban agriculture in Kathmandu 2 years ago. What essentially it shows is that the food basket of Kathmandu Valley, which has ballooned to that stage now, is essentially dependent on food that's produced outside the country, food produced outside Kathmandu, and very little food is produced within the valley. So if you look at the numbers, the import of cereal food has doubled in just about 2 years, from about 4.9 billion to 2.2 billion, and it's going up. So it is turning the city into a city of consumers rather than producers, and it has all kinds of social and political implications. Then let's slap in climate change in this complexity. What that means. Now this is IPCC 5. It says presently what we have is a monsoon land dependent system. We have a circulation of the monsoon. Water rises. You have warm ocean. You have sort of a warm land, and it goes. And then you have aerosols, and you have solar radiation, and moisture comes down. What happens in the future? According to AR5, it says there will be more moisture, there will be more aerosols, more rainfall coming in, but the circulation will weaken. Now, what does that mean for the rainfall characteristic that I stressed? What does it mean for these larger climate systems, the Arabian Sea and the Bay of Bengal stream? What happens to the westerlies? What happens to these meso-level characteristics? And what happens to the micro-level characteristic of the rainfall? And we do not have enough rain gauge stations in these areas to record what happens in these different valleys, where I think the study funded by ESPA in using citizen science provides a window of opportunity in perhaps establishing you could do things differently. You could do things much more in a cost-effective way by involving citizens, the civil society actors, the community groups, etc., and then yet add on to the quality of understanding about monsoon. Now, then science tells us, like everywhere else, that the temperature is going to go up, the precipitation is much more uncertain. This is based on the AR4 scenarios, not the RCPs. It still says that use 15 different circulation models, and there is unanimity of the models for all the different seasons, the monsoon, pre-monsoon, post-monsoon, and winter. The temperature in Nepal in 1930, 1960, and 1990 would go up, but precipitation would remain uncertain. Clearly, on relation to floods and what happens to water, broadly we have an idea of what the solution set would be. We deal with floods, we deal with storms and droughts and mitigation, but up to a certain threshold. The question of water availability, access, the question about disease, about controlling disease, and the questions of who benefits, who controls, who decides, who is represented, etc. These questions that we discussed elaborately, last 2 days. Other question, while rainfall and precipitation have been looked at, I would argue that temperature we really have not looked systematically and deeply. Just not temperature, it's also heat. And heat includes humidity, and humidity is a factor which is part of our metabolic cooling process, and that, I would argue, is also something important. So temperature, humidity, and precipitation. Yeah. Now, temperature regime in Nepal. Historically, if you look at the historical data, the rise in temperature is about 0.06 Celsius per annum, and as you go up in the mountains, the temperature rise rate is higher. The models tell us that by 2090, the rise could be as high as 4.7 degrees Celsius on the basis of baseline from 1970 to 1999. It also says, compared to that baseline, the hot days and hot nights would increase by 70% and 93% by 2090. And this is also something that is corroborated by what communities, what farmers, what all of us experience. Days and nights are becoming more hotter. What is the implication of this story? Our group, I said, recently concluded a study in Gorakhpur in India. Sorry, yeah. And this is a paper that's coming in Nature and Climate shortly by my colleagues. What it highlights is that heat really is an emerging issue and you can't really escape it. What does that mean? And this is, we worked with National Center for Atmospheric Research, NCAR in Boulder, to explore what might be the future of heat. Now, Now this is where I come to a little bit of a iffy terrain because this is not my area of expertise. But nevertheless, I'll try to share with you, what this means. Details, we need to go back to NCAR. Now this is just a chart of what's called a humid index, temperature and humidity together. And what we have is an apparent temperature. So if you have 36 degree, if you have both high temperature or high humidity, the comfort level or discomfort level goes up. And there is a threshold around this, something like about 37 degrees Celsius. What this study found in Gorakhpur was that in a period looked at from 1950, the number of days where the heat index, temperature and humidity combined, was 37 was about 50 days in a year, and by 2050 it will be about 150, 3 times increase. It also showed that in 1950 we had about 4 months where heat index would be close to 37 degrees Celsius. We are approaching an era where it will be about 7 months. Now this map, again, an ensemble result of 12 different models. It will demonstrate that by 2060, these are the months where the heat index would be closing 37 degrees Celsius. Now I'll tell you a story. This year in Kathmandu, it was hot, it was also humid. It was a bit uncomfortable, and I bought a air conditioner. We never use air conditioner in Kathmandu. We thought Kathmandu was a natural air conditioner, but we had to buy air conditioner. I could buy it because I had money. But then Kathmandu has 16 hours of load shedding, so run my air condition, I have a diesel generator. So I know it is bad like smoking, but because if I don't do it, then I don't work, I don't survive. My work stops. So the implication is then that, yes, what do we do about it? What does it mean for these provisioning, regulating, cultural and supporting services of ecosystem? What happens to agriculture? Is it an issue that we need to examine? And we argue it is. Now this has major challenge, because what temperature threshold does is to force us to behave in a particular way. Now what is that threshold, and how do we deal with it? Clearly there are solutions, technical solutions, but also social, political and economic, and we really don't know what the solutions are. But it is cooling. We look for cooling. So when you have temperature high and humidity high, the ambient conditions become so uncomfortable. So if you have, even if you have fan, it's not going to be comfortable. Now what happens in slums? What happens in kind of area that some of us talk about this afternoon and yesterday afternoon? Clearly we need strategies, but what kind of strategies, which strategies, and how do you do it? And that brings me to this whole question of adaptation and resilience. So for many of us, the challenge that climate change poses, things like drought, things like floods, clearly we can build on elements of technology, and we have social organizations on which we can dovetail, we can twin, we can work to build resilience or to build adapt. Yes, there are lots of things that we need to do with existing systems. But what we do deal with heat. Clearly, the threshold is fairly sharp, and we need active cooling. I remember in Dhaka in CBA 8, Atik Bhai, we were out, the humidity was very high, I think temperature was 33. I was out for an hour, so uncomfortable. I rushed back into the, the cool of the mall and cool of the, the hotel. So it has clearly implications for technology. It has implications for energy, economic pathways, access and equity issues. And what it does is to add one more tough layer on already tough current challenges as far as climate change is concerned. Now, what are the current challenges? The first is dealing with attribution. The whole question of climate change uncertainty, the modeling, localizing, the climate change impact vulnerabilities is global, but impact is inherently local. But how do you relate that local with the global? And then of course now you have the RCP. So this is one challenge. Other one is for countries like Nepal dealing with this development adaptance continuum. How do you attribute? What is the additionality? Clearly, this is a challenge. And third is, how do we link planned adaptation with autonomous adaptation in our part of the world where bulk of the response occurs in the informal sector? And that's something, again, we talked about this morning. To what extent do you bring in informal sector into the formal? How do we do it? What are the risks and what are the opportunities? And what are the stories on which we could build our strategies? Clearly, no clear specific answers, but these are the existing challenges, and we're trying to find some answers to these challenges. Now, to bring these stories together, these concerns together, let me present to you what we call as a part of our climate resilience framework. What it does is to look at climate change vulnerability in a holistic way by thinking about exposure, thinking about agents, and thinking about systems. Exposure to climate change encompasses the direct and indirect impacts that affect systems and agents. You could have systems, including ecosystems, which form the foundations, and we all respond to stress by taking advantage or taking opportunities from systems. And then there are agents which are impacted by lack of access to benefits or services from the systems or those who operate the system. And then there are institutions, the rules of the game, the norms that mediate who has access, who has no access to systems and the benefits they generate. So clearly, when you have high exposure intertwining with low capacity agents, fragile system, the vulnerability to climate change is highest. And then it gives us a point of entry into begin to unpack these different elements, conceive them in a holistic way, and to see where you might intervene in addressing vulnerability or conversely build resilience and deal with the changes. We can think of some characteristic of resilience, and this is again part of our work that we're doing in urban and rural areas in South Asia and Nepal. We can think about systems, and we can think of flexibility and diversity as one of the characteristics. Redundancy and modularity, elements that can be replaced and fail safe as the systemic characteristics. Agents which are resourceful, agents which are responsive, and agents which have ability to learn will be characteristic of resilience. And then, of course, institutions. You need to look at the issue of access rights and entitlements, the whole question of marginality, and etc. What is the decision-making process? This is again something that we talked about yesterday and this afternoon. What kind of principles do we follow in governing particular resource? Instead of good governance, there was a suggestion of talking about enough governance. But anyway, that debate is good. How is information flow? Is it transparent or is it not transparent? And is this institution able to apply new knowledge? Now that's the challenge, because the context is so dynamic, changing so fast, that you have to have that ability to learn and change your strategy, apply new knowledge, and then respond to the stress as it emerges. So this gives us a framework and a kind of a tool, a heuristic device, if you will, to begin to respond to some of these challenges. Now let me pose these questions, and I have a last slide where I will put some thoughts. The questions I pose is, which ecosystem and services are most vulnerable within this changing fluid mosaic that I painted? And what does their interdependence with larger systems tell us about their current vulnerability? Which individuals, households, communities, and systems are going to be more vulnerable due to climate change? How will climate change, temperature, moisture, heat, etc. affect the services, the interdependence, and those dependent on the services, and then how that vulnerability will change? How can resilience of natural and human-built systems be enhanced so that people are better prepared to deal with the stress that climate change may engender. And finally, who should be involved in this process of building resilience and how? What are the practices on which we could build on? I'm sure you could just go on adding these questions, but it seems to me, I would just flag these questions. Now let me end by putting some concluding thoughts. Clearly for developed countries such as Nepal and societies which have various challenges within even developed countries, climate change creates a new stress in the well-being journey. It adds that additionality. The questions we're repeatedly asked is, what is it you are doing different? What is it you are doing different that responds to climate vulnerability? Why is your adaptive and not maladaptive? How would you ensure that your adaptive response or options that you suggest today, 5 years down the line, does not become maladaptive? How do you ensure that? How do you ground or dovetail or relate your suggestions with the strategy that people are already doing? The power, the differentials, the daily hurly-burly of life. But then what it does is to add to governance deficit. It lowers development and poverty alleviation gain. Now, if then in this context, if we think of adaptation as a planned response to specific projected impacts that climate change brings, then we'll have to think about specific targeted response. But then if you think adaptation or resilience building as an ongoing process within this complex, evolving system, changing system, then we need approaches or mechanisms or strategies that addresses points of vulnerability within the fluid mosaic. I again would like to use, this changing. You might think that it's like this, it's like a ice in the river, and when it breaks, it's at sharp edges. But as time progresses, the sharp edge sort of, ends, and it becomes messed up with the flowing water. So clearly, what we need is an approach that must be pluralistic, that must be incremental, and then that has to give space for reflective learning and strategies. How to do that? Clearly, this platform, I would argue, opens up that platform for conversation and dialogue where we begin to look at some of these questions. Thank you very much for your time.